Okay, so part A wants us to complete a table of values showing the cost of the pizza with up to 6 additional toppings. Okay, so the cost of 0 toppings would be just the $9. Okay, and the cost of 1 topping, well, it would be $10.50. It would be the $9 plus $1.50. Okay, and the cost of 2 toppings, well, we would add on another $1.50. So we would get $12. And for 3 toppings, we'd get $13.50. Okay, 4 toppings, we'd get $15, $16.50. And for 6 toppings, we would get $18. Okay, if you want to take a look at the equation for this, the equation for a partial variation is in the form y equals mx plus b. And b is your starting point. Okay, starting point. And we already said m is the constant of variation. Let's just say COV, constant of variation. So we would have the cost would equal $1.50 per topping. Do we use T? And then we would have to pay, no matter what, the starting cost is $9. Okay, and we can get any of these values by either continuously adding $1.50, so plus $1.50, plus $1.50, plus $1.50, and so on, or we can use the equation. Okay, and B wants us to graph the costs. So we always have a title, cost of Pete's Pizza. Okay, the x-axis is going to be the number of toppings, and we use T, and the y-axis is going to be the cost, and we use C. So 0,9. Okay, 0,9. And I'll write that down if you want. I can list them. So 1,1050. Let's go to 1 topping, and it's going to cost $10.50. Okay, and 2 toppings is going to cost $12. So 2 toppings is going to cost $12. 3 toppings is going to cost $13.50. 4 toppings is going to cost $15. And if you take a look at the scale that I used here, okay, so 1, 2, 3, 4, we're going up by 1 topping each time, and that's fine for the t-axis, okay? But on the c-axis, let's finish that. I'm going up every 2 boxes is going to be 3, because for nice numbers, if you take a look right here at like the 150t, if we multiply 150 by 2, it's going to equal 3. So pretty much 1 box is going to be 150. So it's just going up by 1 box. But that actually represents $1.50. Okay, so 5, 1650 and 6, 18. Go 5, 1650, 6, 18. And after that, we can pretty much pattern, because it's going to go, just like when we learned slope, it's going to go up 1 over 2, up 1 over 2, up 1 over 2. Okay? And we can pattern with that. So this is a line, and we know that it's direct variation because right here, it does not start at the y-intercept, or the y-intercept is not at 0, 0. So for C, we can write this is, it's still on, this is, there we go, we're on black again. This is a partial variation, since the line does not start at 0, 0, there is a base cost of $9 for the pizza. Okay. Question D asks us, what is the constant of variation and what does it represent? Okay. So the constant of variation is $1.50, and it represents the cost of an additional topping on the pizza. Okay, and question E asks us, using the graph, estimate the price of a 9-topping pizza. Okay, so this is important. This is called extrapolation. So far, we only actually went up to 6 toppings. So what's going to happen is you want to take your graph and you want to continue to extend it. Okay? And then how you do extrapolation is that we know that we want a 9-topping pizza. Okay, so you go to 9 and you just draw dotted lines all the way up. Okay, it intersects the line right here. So now let's line it up over to the left to the cost of the pizza. And I get right here. So what is the number between 21 and 24? I get $22.50. And I know this question didn't formally ask for the equation, but we found the equation up here. Cost equals $1.50t plus 9. So let's just double check. Cost equals $1.50t plus 9. So if we actually had 9 toppings, a 9-topping pizza, we'd go 150 times 9. We'd get $13.50 plus 9, and you get $22.50. So we can check it like that, or we can do extrapolation. So extrapolation, again, is estimating outside of the actual graph.